Good morning. Let us see the MATLAB code for Huffman coding. Huffman coding is a data compression technique which is used for lossless data compression. So which are used in digital communication systems. So it will minimize the redundancy bits present in the symbols, and the main intention of Huffman coding for data compression. Okay, let us see the MATLAB code for Huffman coding. Here we need to take the number of symbols and corresponding probabilities of the symbols. So before explaining the MATLAB code, I will explain the theory part behind the Huffman coding. This is the example given for the 4 symbol with the probabilities for each symbol. Initially what we need to do, the given probability must be written in terms of decreasing order. And I will explain the theoretical calculation that the flower bracket, it represent we are combining the probabilities, lower probability initially. So that here after adding these two lower probability, after keeping the probabilities in the decreasing order, 0.2 plus 0.1 it becomes 0.3. And here one more thing in the Huffman coding, the Huffman coding procedure has two ways. One is as low as possible, other one is as high as possible. So after adding the number, if it is as low as possible method, then that after the addition the combined probability must keep it at the bottom of the column. So this is the method what we have followed is as low as possible. So 0.3 we need to keep it at the bottom. Later again the last two probability, lower probabilities are added. After the addition it has become 0.6. Again we need to keep it in the decreasing order so that 0.6 comes on the top of the 0.4. And finally once we get to only two probability left at the end, then we need to put the code correspond just in front of this probability. So initially 0 for 0.6 and 1 for 0.4. Later it must be back propagated, or we need to go backward to put the codes for each and every probabilities. So 0 comes under 0.6, so that 0.6 is the result of 0.3. So we need to propagate backward with the 0 values, but 0.4 will remains one code itself for the 0.4 throughout the table. So here 0, so that it will be given with the 0001. Again for the next 0.3 it is 01 actually, that must be kept with the 010011. Okay, so the value whatever the 1 has given for 0.4, it remains as 1 only, but other values will be depending on the result addition of the probability. So final encoded data is 100010011. Okay, so in the MATLAB also we have written, this is a MATLAB code for Huffman coding. Here the initially x represent, enter the number of symbols. For example, if I enter 4, the n value 1 to x means n value will take 1 to 4 value. The number of symbols n will be displayed. P means the corresponding probabilities of the symbols P, and after that we need to sort, or we need to arrange those probabilities in the decreasing order. So sorting S will hold the value of the decreasing order of the probabilities, sorted probabilities. Later dict, average length. This function which generates the binary Huffman code dictionary dict for the source symbols by using the maximum variance algorithm. And also this function returns the average code word length of the dictionary. So dict holds the binary Huffman code, and average length, it will calculate the number of bits per symbol, and the same value will be displayed here, average length. Later, average length and entropy, H represent entropy. So here we can see the calculation, theoretical calculation. Average length means this is the number of bits per symbol. Average length, average number of bits per symbol will be calculated by the formula summation I is equal to 1 to 4 pi li. So probability multiplied by the length of the code. So here the length of the code, in the previous table we can observe here, length of the code for 0.4 is only 1 now. Length of the code for 0.3 probability is 0, so length is 2. For probability 0.2, the length of the code is 3, 0, 1, 0, and 0.1, the length of the code is 3. So here 0.4 into 1 plus 0.3 into 2 plus 0.2 into 3 plus 0.12 into 3. So this is the average length of the code. Number of bits per symbol is 1.9 for the given example. And entropy means it is the average number of bits of information per symbol from the source. So H of S is equal to pi log base 2 1 by pi summation. So same formula as written here, H initially is equal to 0, H plus pi into log base 2 1 by pi. So entropy will be calculated, that represent average number of bits information per symbol from the source. And finally efficiency will be calculated. Efficiency can be calculated by H of S divided by L, entropy by average length. So it is 97.15 for the theoretical calculation. And later code word is equal to Huffman enco n comma dict. So this particular function will calculate the encoded data. So it encodes the input symbol n using the Huffman codes described by input code dictionary dict. So actually code word holds the encoded data in row wise, but dictionary, it will calculate the binary number. So you can observe here in the workspace, dictionary has the codes what we got from the table here, same value will be represented here, so that this represents the code word, but it is written in the vector form. But the same code word will be written in the code word in a row wise. So this is the final Huffman encoded data. Okay, Huffman encoded data. And here, after calculating the encoded data, again we can regain we can receive the original data by decoding function. Huffman decode code word comma dict, we will get the decoded data. So I will show the output. Enter the number of symbol. For the same example, I will show 4 symbols. So number of symbol 1, 2, 3, 4. N will holds the value of the symbol 1, 2, 3, 4. Enter the probabilities. Same example 0.4, 0.3, 0.2, 0.1 now. So these are the symbols we have considered in the theoretical calculation also. So it will generate the initially probability has entered. After that it will be sorted in the decreasing order. The average length of the code, what we have observed here, same calculation, the 0.4 into 1, 0.3 into 1, 1.9 bits per symbol. Same 1.9 will be the average length. Entropy, this is the average number of bits of information per symbol, that also 1.8 we got theoretically, even in the MATLAB code also 1.84 is the answer for the entropy. Then efficiency 97%, same we got in the efficiency using the same formula. Then the code words are 1, 0, 1, 0, 0, 0. This is actually, it has calculated with the help of as high as possible way, and decoded it. Again we got the same symbol. So this is about the Huffman code. Actually, this is the Huffman code used for data compression. So it will remove the redundancy bits in the information what we have transmitted from the source to destination. Thank you.